guys, I'm going to go through your chapter review with you. So here we go with number 1. Determine if the point 1, 1 is a solution to the given system of equations. So in order to do that, I need to plug this x value and this y value into each of the two equations. And if I plug those in and the first one equals 7 and the second one equals 4, then the answer is yes. If either one of those does not work out, then the answer is no. So we'll start with negative x, so that's negative 1, minus 8y, so that's minus 8 times 1, equals 7. So that's negative 1 minus 8 equals 7, and that would be negative 9 equals 7, and that's not true. So the answer is no. Now, if this was a true statement here, then I would need to plug that into the other equation. So that would be 1 minus 3 times 1 equals 4. So that's 1 minus 3 equals 4. And that's negative 2 equals 4, and that's not true either. So it actually doesn't work in either of the two equations. In order for this answer to be yes, it has to be a true statement for both of the two equations. It's not true for either of them, so that's a no. Next, we're going to solve systems of equations by graphing. Probably the easiest way for both of these is to get y by itself. So in this first equation, I can move that negative 7x to the other side of the equation, and I'll get negative 2y equals positive 7x plus 6. And then I can divide every term by negative 2. So that's y equals negative 7 halves x, and then 6 divided by negative 2 is negative 3. So I have a y-intercept of negative 3 and a slope of negative 7 over 2. So that's down 7, right 2, but that's not going to fit. So I'll go up 7 and left 2, and that's right there. Okay, so those are the only 2 points I'm going to fit on this graph. So it's going to look about like that. And then for this equation, all I have to do is divide every term by negative 2. And I'll bring that down here. So I get y equals negative 1 half x plus 3. Okay, so I have a y-intercept of 3 and a slope of negative 1 half. Down 1, right 2. And then up 1 and left 2. So the second line, I'm going to miss my spots there. The second line looks about like that. They intersect right there at negative 2, 4. So negative 2, 4 is my solution. My next lines, if I divide every term by negative 1 here, I'll get y equals negative 2x plus 3. So that's a y-intercept of positive 3 and a slope of negative 2. That's down 2 and right 1. And then up 2 and left 1. And then this line, I need to take that 2x and move it to the other side. I get y equals negative 2x plus 3. Another y-intercept of 3 and slope of negative 2. That's exactly the same line. Okay, so when one line falls right on top of the other, that means there's an infinite number of solutions. So any point that falls on that line is a solution to that system of equations. Okay, next up we will solve systems by substitution. Okay, so when we solve by substitution, we want to get one variable by itself, which is already the case right here. Y is already by itself, equals x plus 1. I will substitute that in for that y right there. So negative 2x plus 4 times x plus 1 equals negative 12. And I'll distribute Negative 2x equals 4x plus 4. Plus 4x plus 4 equals negative 12. Negative 2x plus 4x is 2x. And I can also subtract that 4 from both sides. Negative 12 minus 4 is negative 16. And divide by 2, and I'll get x equals negative 8. Now I can take that negative 8 and substitute it into either one of these two original equations. Top one would probably be the easier one. So y equals negative 8 plus 1, and negative 8 plus 1 is negative 7. So that means my solution is negative 8, negative 7. It's always a good idea to plug x and y into the first equation and the second equation and make sure it checks out, just like what we did up here in number 1. I'm not going to do that in the video here, but this will check out. We'll move on together to number 5, but there's never a reason to finish one of these and not check it and make sure that you know you've got the right answer. So for number 5, I can get x by itself pretty easily by moving this 4y to the other side. So I'll get x equals negative 4y plus 24. And I can plug that in for this value of x right here. So I get negative 8 times negative 4y plus 24 plus 7y equals 3. So I can distribute, and negative 8 times negative 4 is positive 32. Negative 8 times 24 is negative, and that's 32y, by the way. Negative 8 times 24 is negative 192, plus 7y equals 3. Okay, so I'm going to add 192 to both sides. And I'll combine these like terms. 32y plus 7y is 39y. And that equals 195. And then I can divide both sides by 39. 195 divided by 39 is 5. So I get a y value of 5. I can substitute that into this original equation. I can even substitute it right here. I think that's going to be the easier route. So I'm going to put it right in here. X equals negative 4 times 5 plus 24. So that's x equals negative 20 plus 24. Negative 20 plus 24 is 4. So we get a solution of 4, 5, and again, it's a good idea to plug those into both of the two original equations to make sure the solution is correct. All right, page 2, solve by elimination. To solve by elimination, I need x's or y's to have opposite values. I think it would be pretty easy to get the x's to have opposite values. So in order to do that, I could multiply the second equation by 3. So I'll have negative 3x minus 21y equals negative 36. And now I can combine the top and bottom equations, and the x's will cancel. 6y minus 21y, and that should actually be a plus 21y. 3 times 7 is positive 21, so 6 plus 21 is 27, so I'll get 27y, and then 9 minus 36 is negative 27, and I can divide both sides by 27. Y equals negative 1. And then I can take that value for y and plug it into either of the top two equations, or the original two. I'm going to go with this bottom one here. Negative x plus 7 times negative 1 equals negative 12. So that's negative x minus 7. equals negative 12. Add 7 to both sides. Negative x equals negative 5. And divide both sides by negative 1. X equals 5. So the solution is 5, negative 1. Once again, good idea to plug 5 and negative 1 in for x and y in each of the two original equations. Okay, in our next set of equations, it looks like it's not going to be quite as simple to eliminate anything. I'll eliminate the x's. Since they already have opposite signs, I'll multiply this bottom one by 9. So that's going to give me 63x plus 63y equals 126. And then I'll multiply the top equation by 7. So I'll get negative 63x plus 70y equals negative 126. My x's will cancel. 63y plus 70y is 133y. And that equals 0. And when I divide by 133, 0 on top, a number on bottom other than 0 is going to be 0. Y equals 0. So then I can plug that into either of the original two equations. I'll go with the second one. So 7x plus 7 times 0 equals 14. That 7 times 0 is 0, so I don't have to subtract anything. Divide by 7, and I get x equals 2. So my solution is 2, 0, and once again, great idea to plug that into the two original equations and make sure that it actually works in both. If not, that means we made a mistake and we need to either find the mistake or scratch it and start over. Number 8. Jill and JD improved their yards by planting daylilies and ornamental grass. They bought their supplies from the same store, so we're going to assume that they paid the same prices. Jill spent $248 on 12 daylilies and 14 bunches of ornamental grass. So my first equation is going to be 12 daylilies plus 14 bunches of grass equaled $248. JD spent $46 on 4 daylilies and 1 bunch of ornamental grass. So 4 daylilies plus 1 bunch of ornamental grass, and that cost $46. Find the cost of 1 daylily and 1 bunch of ornamental grass. Okay, so we can choose either to use substitution or elimination. I'm going to choose substitution. So in this bottom equation, I'm going to move this 4d to the other side. So I get g equals 46 minus 4d. Okay, and I went with capital there, so I'm just going to change that lowercase to a capital. Okay, so I can take that value for g and plug it in right there. So I have 12d plus 14 times 46 minus 4d equals 248. Okay, then I'm going to distribute 12d plus 14 times 46, that's 644. And then 14 times negative 4 is minus 56d equals 248. Okay, so we've got a 644 that we can subtract. And we've got some like terms, 12 minus 56, that's negative 44d. And then 248 minus 644 is negative 396. And then if we divide by negative 44, we get daylilies at $9 per daylily. Okay, So we've got the cost of one daylily, now the cost of one bunch of grass. I'm going to plug in right here. So one bunch of grass is 46 minus 4 times 9. Okay, so that's 46 minus 36. So we find that the grasses are $10 per ornamental grass. The length of a rectangle is equal to double the width. Okay, length is double the width, so that means L equals 2 times W. If the perimeter is 46 inches, find the length and the width. So perimeter, that's 2 times the length plus 2 times the width, is 46 inches. Find the length and the width. Okay, so I'm going to take this value for L and put it in right here. So I get 2 times 2W plus 2W equals 46. So that's 4W plus 2W is 46. And those combine to make 6W is 46. So I'm going to divide both sides by 6. This will simplify to 23 over 3 inches. So that's the width. Now I'll plug that in right here. The length is 2 times W, so that's 2 times 23 over 3. Okay, and that 2 is 2 over 1, so that multiplies to the length being 46 over 3 inches. Okay, on to our last page. So we are now solving 3 by 3 systems of equations. Okay, so we need to decide what we want to eliminate, and it kind of looks like B's are going to be the easiest to eliminate because all 3 of them have a 4. So I'm going to combine these top 2 equations. Negative 3a plus 6a is 3a. The b's cancel. The c's actually cancel also. Then negative 9 plus 24 is 15. So I'll divide both sides by 3 and I get a equals 5. So in my solution, I've got 5, then b, then c. Okay, so I could combine these bottom 2 equations next, or the top 2. Actually, let's do the top 2 because the b's are already set up to eliminate. So I'm going to combine those top 2 equations together, and the a's actually eliminate. It's negative 3a and positive 3a. The b's eliminate. Negative 6c plus 2c is negative 4c. Negative 9 plus 13 is 4. And I can divide by negative 4 and get c equals negative 1. Now I can plug a and c into any of the 3 original equations. Let's go with the bottom one. 3 times 5 plus 4 times b plus 2 times negative 1 equals 13. So that's 15 plus 4b plus negative 2 equals 13. 15 plus negative 2 is 13. So that's 13 plus 4b equals 13. Minus 13. 4b equals 0. And divide by 4. B is 0. And it would be a great idea to take A, B, and C and plug it into all 3 equations. It's possible to plug them in and it works in 1, even 2 equations, but not the third. make sure you plug your answer into all three equations. Okay, on to our final problem. In number 11, I want to eliminate c. So in order to eliminate c, I'm going to multiply this second equation by 2. So I'll get negative 6a minus 6b minus 4c equals negative 60. Okay, so that's going to eliminate c's for me. So when I combine these two equations, I'll get negative 12a minus 8b equals negative 60. Okay, then I need to eliminate c's again in these bottom two equations, so I'm going to multiply that middle equation by negative 3. Okay, so I get negative 3 times negative 3, that's 9a plus 9b, then plus 6c equals 90. And I'm going to combine these two equations. So I get 14a plus 11b, and that equals 75. Okay, so now I have two equations with two variables. So this is my 2 by 2 system. I'm going to rewrite that system down here. Negative 12a minus 8b equals negative 60. And 14a plus 11b equals 75. Okay, so I'm going to solve this system of equations to find a and b. And when I'm done with that, I'll go back up to the original and plug into one of those three equations to get c. So in order to eliminate, I think the easiest is going to be b's. So I'm going to multiply this bottom one here by 8. So I've got 14 times 8, that's 112. So 112a plus 88b. And then 8 times 75 is 600. And I'll multiply this one by 11. Negative 12 times 11 is negative 132a. Negative 8 times 11, negative 88b. And 11 times negative 60 is negative 660. So b's cancel. 112a minus 132a is negative 20a. And that equals negative 60. And then I can divide by negative 20. And I get a equals positive 3. So I'm going to take that 3 and plug it into one of these two equations up here. I'll go with this one right here. So I've got 14 times 3 plus 11b equals 75. 14 times 3 is 42, so minus 42 on both sides. 11b equals 33. And divide by 11, and I get b equals 3. Okay, so for my answer so far, I've got 3 and 3 for A and B. Still need C. So I will plug A and B into one of the three original equations. Let's go with this bottom one. 5 times 3 plus 2 times 3 minus 6C equals negative 15. So that's 15 plus 6, that's 21. So 21 minus 6c equals negative 15. I can subtract 21. So I'll get negative 6c equals negative 36. And divide by negative 6. And I get c equals positive 6. So there's my solution. Good idea would be to plug that into all three of the original equations.